In this next video, we'll be looking at the 6 trig functions in a triangle. So if we start off with a triangle here, or a basic right triangle, and we go ahead and say that either one of two things is happening. Either we're going to go ahead and start off with the sine of theta, say equaling to 3 over 5, or I can give you the triangle, call this angle theta, and tell you that this side opposite is 3, and this side in the hypotenuse is 5. Now remember, every time that we're looking at these triangle works, the idea is if I pick an angle, again, it can't be the right triangle, it has to be the other two angles. That angle there, the opposite is the one across from it. The hypotenuse is always the side across from the right triangle or right angle. And then this side right here is the one opposite the other angle that we didn't pick, and that is called the adjacent side. So now, I might give you this, or I simply might give you this as a starting property, and I might ask you, find all 6 trig functions. Well, if I've given you one, it should be really easy to find the next one, the reciprocal of this one. But what's important first is that we need to fill out this triangle. Again, if I've given you this, fill out this triangle, start. Now, for me to finish off this triangle, I need to know what this side right here is. Well, if I go ahead and use my Pythagorean theorem, which again we will call is a squared plus b squared equals to c squared, more appropriately, leg squared plus leg squared equals to hypotenuse squared, I end up with 3 squared plus b squared equals to 5 squared. And in this particular example, 3 squared is 9 plus b squared minus 25. If I subtract 9 from both sides, I get b squared is equal to 16. Now, if I solve for b should be equal to plus or minus the square root of 16, which is really plus or minus 4. But since we're working with a length, again, since this is a side length, then we should be always picking the positive case. So this side right here will be 4. Now that I've finished out this triangle, my next step is to go ahead and solve for all the 6 trig functions. Well, I know what sine is already, so that one's done. I'll throw that one in a box. I need to figure out what cosine is, and again, from this angle, I'm going to go to adjacent side divided by the hypotenuse side. So I'm going to have 4 over 5. So there's my cosine. I'm going to go ahead and look at tangent next. Tangent, again, you can either take sine and divide it by cosine, getting you 3 over 5 divided by 4 over 5, where the 5's will cancel out and give you 3 over 4. Or, looking at the triangle, I could do opposite over adjacent, giving me 3 over 4. Then we're going to have the reciprocal functions. Now at this point, to be honest, I wouldn't even look at the triangle anymore because I have these 3 basic trig functions. These 3 basic trig functions will correlate to the reciprocal functions. Again, sine goes to cosecant. Cosine goes to secant, and then tangent is cotangent. Now when I say is or correlates or is similar to, what I mean is again, sine, cosine, and tangent, their reciprocal functions respectively are cosecant, secant, and cotangent. So that's right there how you were to find all 6 trig functions given a triangle or given at least one single trig function value.